Hi there. So it is my great pleasure to introduce my fellow Californian, Johanna Drucker, who is a distinguished professor and the Bressler Professor in the Department of Information Studies at UCLA. She is internationally known for her work in the history of graphic design, typography, experimental poetry, fine art, and digital humanities. Her most recent book, Inventing the Alphabet, was published by the University of Chicago Press just recently in 2022, 2 months ago. And other new titles include Visualization and Interpretation, which was published by MIT Press in 2020, and ULiège, Meta-Biography of a Modernist, which was published by Johns Hopkins University Press in 2020. So prolific. And with Introduction to Digital Humanities, which was published by Routledge in 2021. Drucker is also known for her artist books, which were the subject of a traveling retrospective, Druckworks, 40 Years of Books and Projects in 2012 to 2014. And in 2014, she was elected to the American Academy of Arts and Sciences. A collection of her essays, What Is, was published in 2013, and Graphesis, Visual Forms of Knowledge Production, appeared in 2014 by Harvard University Press. Then this is what I remember having you in for this to USC. She published with Ann Burdick, Peter Lunenfeld, Todd Presner, and Jeffrey Schnapp, Digital Humanities in 2012. Other work includes diagrammatic writing, Fabulous Feminae, The General Theory of Social Relativity, Downdrift and Echo Fiction, and Off-World Fairy Tales with Susan B. And with, I didn't name all the publishers, they're many and interesting, but without any further ado, I give you Johanna Drucker.
Thank you, Virginia, and thank you all for your patience and for letting me join you this way remotely. I'm going to launch right into my talk, and I want to start with a quote from the poster, the affiche for the conference, and because my talk really is directly addressing the issue that it raises. In the current digital state of the art, algorithms are the fundamental mediators between immanent computer operations and transcendent cultural production. So it's that gap, it's that relationship that I want to look at in invoking the idea of images after optics and augmentation technologies beyond the visible spectrum, and to think about how computer mediation and algorithmic processing work within belief systems of what I would call, and a term that will be familiar to all of you, the technological imaginary. So I'm going to start with this James Webb telescope image. Okay, so this is kind of an amazing piece of fiction that was created out of very complex signals. Now, just in terms of vocabulary, non-optical telescopes actually are processing light, but they're processing light beyond the visible spectrum. So it's important to recognize that the entire electromagnetic spectrum, it has to do with, signals, and that can be also understood as photons. And the infrared that the James Webb telescope is able to pick up is light, right? But it's so faint because it's so old and it's so far away. And again, we've got all this mythology surrounding this, that the images that are sent images, that the signals that are sent back to Earth are almost entirely black. And so what you're looking at here is a landscape, right, of mountains and valleys and glittering stars. And it's this, edge of a young star forming region that's called NGC 3324, and it's in the Orion Nebula. So this is a complete science fiction image in many ways. And it's put together by a team of people working with the signals that come back from the James Webb telescope. And one of these individuals, Joe De Pascali, described the way this works. And he says this, the images come back, they're almost black. Every pixel that is generated by those signals has the potential to be one of 65,000 shades of gray. I mean, this is like mind-boggling, right? 65,000 shades of gray value can be assigned for every single pixel. And so what they do is they process those signals in order to distinguish their wavelengths, even though this is like all shifted all the way over into the remote area of the infrared spectrum. And they take those signals, and by parsing them algorithmically, and Pascal says it takes about 5 hours to process these signals. And you can imagine they've got kind of like mega computers, right? And so 5 hours, but they create a value scale so that there are still, lower and higher values. And then using that scale from within that black image, they create this by assigning a red value to the longest wavelengths, a blue value to the shortest wavelengths within that very narrow scale. And then they assign color values in between the red and the blue. So this is kind of amazing to think about, right? The wavelengths are translated into relative color values, and then it produces something that looks like this. So this is light, but it's not visible light. And this is an imaging effect, not a photograph, right? It's you couldn't take a picture of this galaxy in that sense. So I want to, again, in terms of vocabulary, this is not, anything novel for all of you, but to distinguish those things that are not visible, like infrared, from things that are basically not visual. In other words, that don't have an inherent visual analog. So we'll leave the Webb telescope here because we're going to come back to it, and think about things that are not visual inherently, and yet come to be representations of belief systems through visual means that then we accept, right? Or in different periods and in different frameworks. So, the winged bull of Lamassu from the Neo-Assyrian period, right? Fine, it's not visual, but it becomes visual through representation. We got all our angels and our devils, right? It's like, they're basically not visual things, but they can be rendered in visual terms according to tenets of belief. And, abstract systems, constructions like the Sephirot, the Sephirotic tree, and very detailed conceptual framework and structure. And again, rendered visual, but not inherently visual. It's a logical form, and it's a structure. Also, there are many phenomena in the world, right, that are not visible. In other words, they are not part of the light-based system. And, the alignment of magnetic particles, even though magnetism is part of the electromagnetic spectrum, but this kind of an alignment, has to do with making manifest in visual form a force field that we can that it isn't visual, right? It has an effect, and we render it. And this is, from those of us who were kids in a certain period remember Wooly Willy, the guy who had the magnetic filings that you could put on his bald head and bulged chin by moving them around. So this was a child's trick, right? But then there are other things that are not inherently visual that get given, graphic form and then made legible in terms of graphic values, relationships, structures, logical constructs. There's absolutely nothing in the, sort of structure of these prize-winning novels listed on the left, and their trail of connections on the right through this elaborate structure that is inherent to the data. Nothing, right? It's just an eye candy piece. And yet, so it's not visual, but it's rendered visual. And again, the tenets of belief allow this to translate into a legible statement that we take as, with varying degrees of skepticism to be an expression of something we believe or don't believe. And finally, in this series, one of my favorite images within this kind of category of the non-visual are images of emotions. And Annie Besant, who is a fascinating figure, did a book called Thought Forms in the early part of the 20th century in order to show the manifestation. This is anger, of course, you can recognize it. It's in the long wavelengths of the infrared spectrum, to again, to make manifest in graphic expression things that are not inherently visual. So the non-visual is one whole category. We're not dealing with that. We're dealing here with kind of optical phenomena that are part of the electromagnetic spectrum that are nonetheless augmented. And this is where the concept of augmentation comes in here. Most of the augmentation we're going to look at is computational, or to some degree, and that's where we're going to go back to this statement about the mediating function of the algorithm. And the point I'm going to make overall, again, it's a point you've probably been batting around in the last 2 days, it's just that there is a conformity that occurs between expectations about how something should look and the historic moment of its production that allows the image to really serve the purposes of supporting belief systems. And so, if you keep that Webb image in mind, the James Webb Telescope image in mind, we'll come back to it in a few minutes, we can see how that's the case, right? It's like, that's what we think a nebula and star formation, activity should look like. So of course it does, right? But there's no reason for it to look that way. I mean, I'm sorry. This is a fabrication. It's an augmentation of data that's been processed through a whole set of operations. So this is our friend, the electromagnetic spectrum, and its whole full range. And this is important because I'm going to talk for a couple minutes here also about radio waves and radar, microwaves, right, and gamma rays and X-rays, and all of these other invisible, but basically, invisible to our eye, components of this spectrum. And think about how they work also to image information through computational or electronic or other means. So we go back to these James Webb images for a moment. Here we are once again. There are multiple processes that go into making these images. Now, I described Giulia Pasquale's, information about the nearly black images getting, and their pixel values and so forth. But it's actually more complicated than that. And if you look at the bottom here, you'll see there's a bunch of little acronyms. And these images are not just processed from a single image source, the James Webb Telescope, but they take into account a whole bunch of other inputs, and they can create multiple kinds of outputs. You see here across these different wavelengths of light, you can identify different elements and components of a galaxy, of a star, to find out what elements it's composed of, and so forth. We have here the continuous curve problem. These are discrete data points. There's no reason on Earth for a continuous curve to be part of this, and so forth. But again, the point here is simply that, this is the world we live in. We live in a world in which, multiple kinds of data sources are brought together, processed through algorithmic activity, and then rendered in ways that make them legible. And really, the question I have is, how do we intervene in that kind of, stream of production to see how these manipulations conform to our expectations? So one of the things that happens to produce the Webb telescope images is that the information is aggregated with other kinds of galactic observations and cosmic observation techniques. So the Arecibo telescope is a huge, it collapsed. It's the huge radio telescope in Mexico. And again, it works with a combination of observation of radio waves and radar. And when the signals come in, they look like this, but when they're rendered legible, they look like this. Well, what's going on there? And, whose expectations are being met here? This looks like the cover of every sci-fi magazine, from my youth, right? So it's like, I know where these come from. And, these things are fantastic technological instruments. Here's the very large array in New Mexico, 27 antennas of 25 meters each. And again, these are working with, optical information as well as radio information. This is a color image from the information gathered by this very large array. And then again, it becomes a kind of, we could call this simply a logic structure, right? But it looks like a picture. And okay, that's where the tricky part comes in. It's like, it looks just like a picture. And then that becomes curious. Now, another area, of course, of information gathering besides radio, radar, electromagnetic, photon light spectrum, are X-rays. And one of the interesting, is the famous Roentgen image of his wife's hand, right? So one of the problems with X-rays is gathering them, because guess what? They pass through things. And so they're harder to capture. Now here we see a contrast between the Orion Nebula created in an optical, quote unquote, view, and an X-ray view. Very, very different. You can see the way in which the discrete information structure on the right is quite distinct from the colorized version on the left. So again, it's like same information, very different rendering. And this is from the Chandra telescope, and that Chandra has this very elaborate parabolic structure in order to, I'm not sure exactly how it works, but it captures the X-rays by having these multiple layers of conic structure to funnel the X-rays into the place where they could be focused and made use of. So X-rays are kind of interesting in this regard. And my favorite particles, the neutrinos, are going through us all the time, and they are not visible. I mean, I don't know how many of you have been watching your neutrino field this morning, but I haven't. It's like not apparent to me. So as a kind of momentary detour here, because it's important to the overall argument about the historicity of images and belief and their intersection with belief systems, I just want to remind us of the constructedness of images in terms of species capacity and specificity. We know the thing that doesn't happen when we, look at the world is that a picture does not go into the brain, right? I mean, and this is always something you have to, it's like in teaching, I'm always like, the students are like, what? I mean, the picture doesn't go up there, it's like, so, it's like explaining to them that when they're on the phone, they're not really talking to somebody. They're actually having a signal process that they're receiving, that they are, and they don't want to hear it, right? They want to think they're talking to somebody in real time. But no, your signal is having a conversation with another signal and you're perceiving it. So it's a big disappointment. So we know that, again, what ends up in the mind is a percept, and a construct. But nonetheless, the optical apparatus through which we get information is one of the fundamental points of construction according to which we come to believe in the nature of that external world. And here you can see the contrast between dichromatic and trichromatic species perceptual apparatus, right? So, we have, only two bands on the left. We have three on the right. Our human eyes are trichromatic in terms of the cones, rods of cones. But all animal vision distributes around very different kinds of perceptual ranges. And this is also really interesting to consider because of the things that are part of our world that are not necessarily part of our visual processing on a regular basis. So again, if we look at the capacities of different species, here are four types of chromatic perception in reptiles and amphibians, where birds and bees have ultraviolet, these bees that can detect UV light, and so on and so forth. Herbivorous primates need color perception, right? but apparently cats do not, right? It explains why they get on mismatched socks in the morning and stuff. So, but again, the naturalization of perception, in a sense, obscures to us the extent to which it's our affordances, our optical affordances, according to which we construct belief systems that then become part of our representational systems, because that's the way we believe the world is, where in fact it's a matter of how we, how the world appears to us as conceptual constructions. And again, we can compensate for these kinds of limitations in our optical apparatus by using, different kinds of signal processing. So you can have full spectrum photography, right, that picks up on parts of the, spectrum that we can't see, produces this kind of special effect image. And again, we render things visual through all kinds of magnetic resonance imaging and computer tomography in order to, extend our capacities prosthetically through various kinds of technologies and apparatuses. And then again, going back to the non-visual, but also ways to render images from signal processing that has nothing to do with photons, like sonar. So sonar is to bounce, right? It's a interference in return that allows a form or a structure to be mapped according to coordinates. But it's got nothing to do with the optical world. There are no photons in sonar until we come to render it in a graphic form. So again, the point here really is simply, and it's a very basic point that again you're all familiar with, is just to say, the conventions according to which we make something legible in visual form have to do with various kinds of constructs of belief, and yet within, again, the fish doesn't see the water it's swimming in, within the kind of current world of the technological rendering of images, we kind of stop thinking critically about that. We take those James Webb images to be a picture of that ancient, star formation. A couple other examples of things that are, not visually based, but can be mapped. Again, we don't see heat, human beings. We can't see heat in the room. Many animals can see heat, and it's the way that they find their prey. So, the hot spots on the cat are apparent here. There are other kinds of, sort of phenomena that can generate graphical representations. Kirlian photography, which is actually, again, a corona discharge, which is electron, it's generated by electricity. So the corona actually has, photons. I'll leave it to you to decide whether you think these things are just hokey and, California kind of stuff, or if there's something, that's actually being captured here. But we do know if you put your finger down on a photographic plate while you're having an electric current sent through the plate, it generates an aura. All right, so there it is. Again, it's these renderings. And what's interesting to me is the fact that some of the stuff is considered sort of like suspect, whereas the other materials and other renderings are considered completely legitimate, and they get a kind of authoritativeness attributed to that. And so one of my questions is, where's that line? Where is the line between that which gets considered ooh, and that which gets considered totally legitimate? All right. So, I don't think anybody's going to argue that the thermal photograph of the cat is somehow paranormal psychology at work. It's like, yeah, we believe in that. All right. Okay. So when we come back then here, as I'm kind of pulling this together, to images that are created within the James Webb Telescope observation, it's like, how different is this from this, right? It's like we have processing, we have some kind of, the field of energy that's being apprehended and rendered in some kind of legible visual form, and then it conforms to certain expectations about what we want to see and how we expect to see it. So for instance, we can't see magnetism here. We don't see gravity. right? Even though in terms of thinking about planetary activity, gravity and magnetism are two of the most important aspects of the way in which the ontological existence of these phenomena can be understood. But we can't render those, so we render the forms and the lighting. So again, as I'm kind of pulling this together at the end here, I put these two images up for contrast, because here we have, hyperspectral data imaging. It's, a whole way of taking the data from across the electromagnetic spectrum, putting it into a graphical representation, parsed according to various kinds of relative values, and given a graphical expression. And again, it's associated with, capture devices like this one. Now, this is one of the earliest radar astronomy sites. It's called the Pluton, and it was built in the USSR in the 1960s. But either one of these images, as we look at them, we do not question their authority. We figure something that's made like this is made not to create science fiction, but to do science. Okay. And so we don't have, it's like, no, this is real. This is the hard stuff. This is real, right? Whereas we take a look at the spirit photograph, from the 1860s or 70s, and it's like, oh, no, that's fake. That's completely fake. And it is completely fake. I mean, these were done in the dark room. I mean, I'm not going to try to suggest to you that a genuine spirit of a dead child is showing up in this image. But I do come back then to the James Webb telescope here to say, this is not fake, but it is a curious kind of augmentation, where the augmentation is done from data moving towards a kind of expectation target, right? What is it that we think will render this data in a graphical expression that makes it believable? What is it that gives it credibility and authenticity? I'm sorry, but those stars with the lens shining, give me a break. I mean, that is not there at the birth of the universe. I'm very sorry. The other thing to think about here, right at the end, so to throw this in, for those of you who are working on your forgery skills, is that, and again, I'm not suggesting that Webb telescope images are forgeries, but I am using the Mona's Lisa here to make the point about the historicity of vision and features, and the features that are considered characteristic of an artwork at a particular moment in time do not age at the same rate as the original. So, and again, you can look at these and start to see differences, not even just mention the composition, but even in two versions, maybe very close to the period. Here, an apprentice of Da Vinci made a copy of the Mona Lisa within a couple of years of the original. And there's no way, looking at these two images, that you can confuse one with the other. I mean, they're completely different in their affect and their color range. And I'm not saying that the apprentice was trying to do a forgery. He was doing a copy. It's a legitimate practice of the time. But the point is that the features that he was picking up on no longer match what we see in the Mona Lisa, right? These things have been rendered differently. And so the basis of belief is, again, where I go back to this, notion of the technological imaginary, that we have an idea that is produced by images and expressed within images of what constitutes authoritative and credible presentations. And when we look at Charles Gilmore's early rendering of a dinosaur that looks like a pine cone on hind legs having lunch, versus the real photorealist rendered dinosaur here on the right, again, you can see how the graphical conventions align with tenets of faith, tenets of belief about how something should appear in order to be given its credibility, its authoritativeness. And, you go back to this is my final slide here, the contrast between, here's Percival Lowell in 1906, rendering the maps of the canals on Mars according to an absolute conviction about what these striations actually represented and then bringing them into focus in order to show that there had been alien life. And you look at the James Webb image again here on the right, and again, what is the belief system according to which it's created, but whose interests it is designed to serve in terms of a certain kind of scientific authority, you know, rendered in a particular way. So that's it. Those are my images beyond the optical range. And I'll stop sharing my screen so that I can see more of you there.
Push that maybe there. Thank you.